My dear students, I'm sure you must have watched the previous videos on spherical mirrors and you must have completed the assignment or the task given there. In this session, we are going to learn about the a ray diagram for spherical mirror. So what way does the ray diagram help us? The ray diagram is used to study the image formed by the spherical mirror. Without knowing the mathematics, those of you who are not comfortable with mathematics, you can predict the image, you can study the image formed by the spherical mirror using the ray diagram. The next advantage of the ray diagram is you don't need to have experimental setup. Without using the candle, without using the stand, and without having the mirror with you, we can predict where the image is going to be formed or what is going to be the size of the image. What you need to make the ray diagram is only a pencil, paper, a graph sheet and a ruler. That is what is required. So let us see how we draw the ray diagram. Before we go to the drawing the ray diagram, if you recall what are the various parameters of a concave mirror or convex mirror. First is the pole. If you see the pole is the point on the mirror which divides the spherical mirror in two parts. Next is the center of curvature. And the next is focal length. If you recollect, the center of curvature is at a distance of twice the focal point. That means the radius of curvature is twice the focal length. And the distance between M and N is called the diameter or aperture of the mirror. And the line joining pole and the center of curvature is called the principal axis. So for a given mirror, let us see how we draw the ray diagram. So to draw the ray diagram, we have four rules. This diagram shows you a concave mirror and this diagram is convex mirror. The concave mirror, as you can see, it is curved inwards. That means the focal point and the center of curvature is towards the left of the shining surface or reflecting surface. So the first rule for the ray diagram is the ray which is parallel to the principal axis. After the reflection, it crosses the focal point. So this line shows the ray of path which is parallel to the principal axis. So after the reflection from the mirror, this line is passing through the focal point. The same is the case with convex mirror. So this is rule number 1, which says a ray parallel to the principal axis after reflection will pass through the principal focus in case of a concave mirror or appear to diverge from the principal focus in case of a convex mirror. So if you see this angle I is the angle of incidence and R is the angle of reflection. So if you recollect the law of reflection, the angle I is equal to angle R. And the normal is, if you join this point with the center of curvature, this is normal to the surface. Now let us see the rule number 2. The rule number 2 says, if the ray is passing through the focal point, if you recollect, this is the focal point which is half of the radius of curvature. So if the ray is passing through the focal point, after the reflection, it will become parallel to the principal axis. In this case, the principal axis is PC and the line, if you see the light is passing through the focal point. And after reflection, it has become parallel to the principal axis. So this is rule number 2. Next is the rule number 3. The rule number 3 says the ray passing through the center of curvature. After the reflection, it will go back to the same path. It will retrace its path. Like if you see this center of curvature, which is twice the focal point, the light is incident on the mirror and it goes back to the same path. So this is called the rule number. This is the rule number 3. The same case happens in case of a convex mirror. If you see the line is incident on the mirror, okay, and this is passing through the center of curvature, and then it reflects back and retraces its path. And the last rule is, that is rule number 4, is again based on the law of reflection. If the ray is incident obliquely, means at an angle, say at the pole, so after reflection, the angle of reflection will be equal to the angle of incidence. So the light ray is incident on the pole P, and after the reflection, it is going back at an angle which is equal to R. So in this case, I is equal to R. So it says a ray incident obliquely to the principal axis. Oblique means at an angle towards the point P on the concave mirror or a convex mirror is reflected obliquely. So using these 4 rules, it is possible to find out the formation of a image on a concave mirror or a convex mirror. So for this activity, you can take this as an assignment. I will demonstrate and you have to do this as an assignment. For a concave mirror, assume that the focal length is 5 cm and the object of size 2 cm is placed in front of the mirror. So applying these 4 rules which we discussed, we'll find out what is the kind of image. So that we'll put the object at different position at infinity, beyond C, that means 12 cm from the mirror. The object will be placed 12 cm from the mirror. It will be placed at the center of the curvature at C, that means 10 cm from the mirror. Then we'll shift the object and it will be between the center and the focal point. So for your case, you will be keeping the object at 10 cm from the mirror. Then we'll put the object at focal point and then between focal point and the pole. So you have to tabulate your results in a format with actual values. So your assignment will look something like this. Make a table, find out the image formation by a concave mirror for different position of the object. So first column, you will keep the object at infinity and note down the position of the image from the mirror, size of the mirror image and the nature of the image. So you have to complete this activity for all the 5 cases: at infinity, beyond C, at C, between C and F, at F, between P and F. So what I'm going to do is, I'm going to demonstrate you one example and then you have to do the rest. In this case, first you have to draw the sketch of a concave mirror. So you take a plain paper and you draw a concave mirror and locate the pole. So the pole will be a half of B and A. So it will be in the center of the mirror. Then you draw a line and a point F, which is 5 cm. For your case, the focal length is 5 cm. So with the scale, you take a point which is 5 cm from the pole. So this will be the principal focal. Then find out where is the center of curvature. So in this case, mark a point from the pole which is 10 cm from the pole. So this becomes C and this becomes F. Now in this case, the object is kept beyond C. So mark a distance 12 cm. From the distance between P and Q will be 12 cm. And the height of the object will be 2 cm. So now you can apply any of the 4 rules. So in this case, we'll apply the first rule. First rule is mark a point on the object. Here is the flame. So this point, apply the first rule. What does the first rule say? The ray parallel to the principal axis, in this case PQ, of the reflection will pass through F. So draw a line parallel to the principal axis. So you know how to draw a parallel line and join this point with the focal principal focus and extend this line. Now you have to apply the second rule. For each point, you have to apply minimum 2 rule. So now you apply the rule number 2, which says the ray passing through the focal point after the reflection will be parallel to the principal axis. So from R, join R and F, extend it, and it will meet at the mirror. And from this, you draw a parallel line to the principal axis. Now you got line number 1 and the line number 2. They are meeting at the point R dash. So that means this R dash is the image of the tip of the flame. Now you draw a perpendicular from this to the principal axis. So this becomes the image. Now you find that the image is inverted. That means the image is real. Now you can find out the distance between the mirror, that is pole, and the image. So this is called the image distance. All the distances are measured from the mirror, that is from the pole. Now you can measure the size of the image and you can measure this distance, and you have to physically use the scale and a pencil. Don't draw a rough diagram, you have to draw exactly. And then you can complete the table. Okay, one more example to help you I will give you. If the object is kept between the focal point and the mirror. Okay, so this is the F and this is the pole. Okay, and the object is between the focal point and the pole. So again you have to follow the same procedure. Here again you can apply the first rule. Draw a line parallel to the principal axis. So after the reflection, okay, that is rule number 1. So it will pass through the focal point. Okay, so this join this point with the focal point. The other is you can apply the rule number 4. Draw a line from this point to the principal axis. Call this angle I. Draw another angle which is equal to the I. Like say this is 20 degrees. So you draw an angle 20 degrees from this point. Okay, and you extend these two lines beyond this. So this will be the virtual image. So in a concave mirror, you can find out if the object is kept between the focal point and the principal axis at the pole, the image form is virtual and it is enlarged. So you can complete other position of the object and complete your activity. Like this, in this case, the object is kept at the center of curvature. So the image is real and the size is same as the object. Again, you can apply the first principle, draw a parallel line, join this point to the focal point, apply the rule number 2, you will find that the image is formed exactly where the object and the size is equal to same. Okay, having completed the ray diagram, where do we use the concave mirror? Because if we study the ray diagram, we will find that the concave mirror is using torches. It is using the searchlights and the vehicle headlights, because it produces the powerful parallel beams. If the light is kept at the focal point, after the reflection, the beam becomes parallel. So this property is used in the searchlight. Okay, this is used for the saving mirror to see the enlarged image of the face. Dentists also use this concave mirror because if you see the last formation of the image, when the object is kept between the focal point and the pole, the image is enlarged. So this is what the doctors use to see the cavity in the mouth. So because the image is enlarged or magnified. And it is used in the solar furnace also. Because the light from the sun gets focused at the focal point. So the energy gets concentrated at the focal point. So these are some of the uses of the concave mirror. Now, if you follow the same principle, you can also find out how the images are formed by a convex mirror. So the principle, all the four rules are same. The only thing is the concave mirror will always produce the virtual image. Okay, the image is always real. So you can do this activity at home. You can take any convex mirror. You can remove the convex mirror of your scooty, motorcycle, or your vehicle, and you can see how the image is changing. You can hold a pencil in the upright position in the other hand and observe the image of the pencil in the mirror. Okay, you'll find that the image is always erect and the size is always small. That is a property of the convex mirror. Okay, and you can complete the next table, okay, which pertains to the image formation by a convex mirror. So kindly note this and complete this exercise in your journal. If the object is at infinity, what is the position of the image, what is the size of the image, and what is the nature of the image. Now the next is, if the object is at infinity and the pole P of the mirror. So kindly complete this activity. So this again is a ray diagram for convex mirror. The principle is very simple. Again, if the object is at infinity, the virtual image will be formed at focal point. And if the object is beyond the focal point, again the image will be virtual and the reduced size. So by applying the law of reflection and the rules of ray diagram, you can find out the images formed by the convex mirror. So where do we use the convex mirror? Okay, as the convex mirror always uses the image formed by the convex mirror is always a virtual. So they are used in the rear view mirror. If you see the mirror fitted in your car or in your motorcycle, it is a convex mirror. Okay, because the image is erect, so the driver of the vehicle should know what is which vehicle is coming and what is the approximate distance. So if the size is inverted, he will get confused. So the rear view mirror is always a convex mirror. This is used for the safe driving. Because they are preferred, because the image form, as you have seen, is always erect and the size is a reduced size. And they have large field of view as they are curved outwards. So the field of view is large, so the driver can see a very large area. So these are the questions, okay, which you can note down in your journal and assess yourself. Define the principal focus of a concave mirror. Find out if the radius of curvature is 20 centimeter. What is the focal length? Name a mirror that can give an erect and enlarged image of an object. And why do you prefer a convex mirror as a rear view mirror in the vehicle? Kindly answer this question in your journals, and I finished. If you have any doubt, you can contact me at my email ID or through the class dojo. Thank you.